All right, so this is an integral where switching the order of integration is necessary, because if you try to integrate sine 3x squared just by itself, you would quickly realize that this is impossible. Just setting u equals to 3x squared and then du as 6x dx makes dx equal to 1 over 6x du. So this becomes integral of sine of u times this thing, 1 over 6x du, and then to get rid of that x, we have to solve for it for x, and then what's that? U over 3 square root is x, so that goes in here, and it just gets worse after doing the u substitution, right? That's not even, yeah, I mean, this is something you can't really handle with u substitution. So there are many integrals where the antiderivatives cannot be written as sine or cosine or any kind of known function. So this is one of them. The antiderivative cannot be expressed. You can't compute it using any of the u substitution, integrated by parts, or any method that you know. Okay? But strangely, if you, as if magic, somehow this question can be computed if you change the order of integration. So let's try that. Okay. All right, so in order to switch the order of integration, the first step that you have to do is first realize that dx being here means that x is this, and that's x is 2. That's what it means. And therefore, to draw the domain of integration, you have to draw the graph of x equal to cube root of y and x equals to 2. Let's try to draw these two. Now this might look foreign to you, but if you take the cube of each side to get rid of this cube root, what do you get? That's y equal to x cubed, right? Everyone should know the graph of y equal to x cubed. It's like this. And then x equal to 2, that's simply a vertical line. And then if I go back, having dx inside, what does that mean?
Going left to right.
Left to right. So you're trying to draw the domain going from left to right. Okay? With your lowest y value being 0 to the highest y value being 8. So from here to there, you're trying to start at this curve and you're ending at that curve. See, this is this curve. This is this curve. So this should be really thought as you start at this curve and you end at that curve. Okay? You start at this thing, you end there. Okay? Going right. So if you do that, you eventually sweep out this domain. And they actually meet at 2, 8, because if you plug in 2 into this function, you get 8, right? So you do have this domain. And therefore, this integral is like an integral over this domain of sine 3x squared and integrated with dA, the area limit. dA could mean dx dy or dy dx. All right, now switching the order of integration is to go from dx dy to dy dx, or vice versa. Sometimes you might be given an integral with dy dx, and you have to figure out the opposite. Okay. For this one, we have to go from dx dy to dy dx. So let's think about that. And having dy inside means, how are you painting this region?
Upward.
Upwards. dy is an increment in the y direction, so you go upwards. dx is an increment in the x direction, you go rightwards. Okay? If you're trying to paint this region upwards, you're trying to go this way. And then, if you view the region in this way, you have to now think about where these brushes begin and where it ends. And you can see that they all begin here, and they end here, right? So basically, you want to say it begins somewhere here and it ends there. Begins here and there, okay? But if you write like this, you can't compute anything. You need explicit equations, right? So let's think about the equation for this. What's the equation of this? Y equal to 0. Okay, it's a horizontal line, so it's like y equal to number. Right? This horizontal line is at passing through y equal to 0, so this line equation is y equal to 0. So that's what this is. So when you see the 0, don't think about number 0. It's not the number. It's the line. It's the horizontal line whose equation is y equal to 0. Okay? That's the way you have to think. If you just think of that as a number, then you're not going to understand what's going on. Okay? All right. What about this? What's the equation of this?
X cubed.
This is y equal to x cubed, right? That was the equation that we had, right? And therefore, we put x cubed here. Now, another thing that I want to warn you is, see here, the equation was given as x equal to cube root of y. So this one curve can be represented as either x equal to cube root of y or y equal to x cubed, but I chose this one. Why? Because if you have dy, this should really be thought as y equals to x cubed. So y equals is not there, but you should really think that it's there. Okay? So you don't want to put cube root of y, because if you put cube root of y, that will mean y equals to cube root of y. That doesn't make any sense. You really want to say just x cubed here. Okay, and then once you integrate the inside, the next thing is you have to figure out the bounds for x. See, I said it's curve to curve from point to point. These are numbers. Okay? These are equations that define curves. These are numbers because once you integrated out the y, it has the effect of just integrating all the y directions, and now it becomes a one-dimensional integral. And in this one-dimensional integral, it's like an interval. So it goes from somewhere to somewhere, right? So what is it? From where to where? 0 to 0. Okay, so that's how to successfully change the order of integration. All right, now let's see why this helps us. Now, integrating sine 3x squared by dy, that's easy. Why? Because if you're integrating by dy, this is considered as just a constant. So you're just integrating 1, for example. If you integrate 1, you get, what do you get? Just y, right? And then here you're trying to plug in x cubed, and be careful, this is really for y. X cubed and 0 goes into y. It doesn't go into x squared. So it's really important that if you have dy here, these are y equals to and y equals to. And then when you plug in, when you replace y by x cubed, this is what you get. You get 0 to 2 x cubed sine 3x squared. And then when you plug in 0, it's 0, so you have to subtract 0, but that doesn't do anything. But this is what you have to do. So put this in here, put this in here, and then subtract the 2, okay? And then you integrate by x. All right? Now let's continue. So that means we have to integrate 0 to 2 x cubed sine 3x squared. And somehow, now it's possible to integrate. Okay? We can say u is equal to 3x squared. That gives you du equals to 6x dx. So that dx is 1 over 6x times du, if you divide by 6x. And we can now rewrite x cubed. I don't know what to do, but I can definitely replace 3x squared as u. And then dx is now replaced by 1 over 6x du. And then because you have u here, the values here should be values of u. Okay, that's one thing that a lot of people forget. Okay? So let's think about this. When x is 0, what's the value of u? If x is 0, u is also 0, right? If x is 2, what's the value of u? 12, because if you plug in 2, 2 squared is 4, 4 times 3 is 12, so You have to put 12 here. I know some people were taught that you don't do that, but you go back to x and then plug in the values 0 and 2 into x. But this is definitely faster, so please try to stick with this method. Okay? All right, so let's continue. I can simplify this. X cubed divided by x is? I can pull the 1/6 out. X cubed divided by x is? X squared, right? And this is dangerous to integrate now because I have x and u mixed. Okay? Make sure everything is in terms of u if you're doing u substitution. Okay? So this somehow has to be changed into u. How do you do that?
You 1/3 u.
Right. You look at this and say, if I divide 3 both sides, 1/3 of u is equal to x squared. Therefore, now I can rewrite it as 0 to 12. That's like 1/3 of u sine u du. And 1/3 times 1/6, that's 1/18 of integral of 0 to 12 u sine u. Oh no. It looks like now we still have to do what? Integration by parts, okay, or tabular integration. So let's do that. Let's do the tabular integration. Let me do the tabular here. Okay, plus minus d integral. What do you put over here? What do you differentiate?
U.
U. You integrate?
Sine u.
Sine u. Differentiate u, you get 1. Differentiate 1, you get 0. You stop because you got 0. Sine u integrates to? Negative cosine. Cosine u integrates to?
Negative sine.
Negative cosine u integrates to negative sine. And then you do this. And then the last line gives you c, so that gives you, let's see, what's the result? This is 1/18. Negative u cosine u. Okay, and then plus sine u. And you're plugging in 12 and 0.
They're not the same.
You don't need it when you're doing definite integrals. Yeah. Plus c is not needed when you do definite integrals. Okay, and then when you plug in 12, what's that? That's 1/18. Negative 12 cosine 12 plus sine 12. And then when you plug in 0, 0 times anything is 0, so that goes away, and sine of 0 is 0. So when you plug in 0, you don't get anything. Therefore, the answer is this. So that's the answer. Any question? Yes?
Can you explain where you got the 1/3 from? Where you went from x squared
1/3.
to-
Oh, here. U equals 3x squared. 1/3 of u is x squared. So I replace the x squared by 1/3 of u. And then 1/3 can be brought outside. 1/3 times 1/6 is 1/3.
Why do we change the 0? If we change the 12, we change the 2 to the 12, but
Oh, okay, so 0, if you plug in 0 into x, you get
It's
the
just
value of u as 0.
okay.
So,
And you're just plugging in the 2, okay.
yeah. Okay, so that's